Welcome to the session on data analysis and visualization. In the previous session, we have seen the different visualizations which can be created by looking at the type of the variables. In this particular session, we are going to deal with how can we conduct the basic analysis using Python and by how to interpret those results. So in this particular session, we are going to learn about what is introduction to analytics, how to conduct the correlation analysis, which is the most important analysis that is to be carried on in order to understand the relationship between the variables, and how to carry out a very simple linear regression model. So hence, let us go ahead and understand what is analytics. Analytics is nothing but the analyzing the data by applying some sort of mathematical and statistical techniques. Now, whenever you are trying to analyze the data by applying the mathematical and statistics techniques, it has been termed as analytics. The moment you go ahead and look at the data, you need to concentrate on three things. One is first try to understand the data and draw some sort of insights, which we have seen during the data visualization session. And to grab the insights, you try to visualize the data and understand that this is the insight what I have got from the data. And based on the understanding of the data, you go ahead and test some sort of hypothesis. You frame some sort of assumptions and you do some sort of hypothesis. So frame some sort of hypothesis and then you will go ahead with the hypothesis testing, which falls under the category of statistical analysis. Sometimes you wanted to find out an association between the dependent and the independent variables, or which means between the input and the output variables. So in such a case scenario, we deal with some sort of machine learning algorithms or predictive algorithms or the deep learning algorithms. So all these three combinations, that is the data visualization to draw the insights, statistical analysis to conduct the hypothesis testing, and the machine learning aspect of understanding the association between the variables is being termed as analytics. So hence, if you see here, we are going to incorporate both the concepts of mathematics and statistics to understand the data very well. Now, having an understanding of what this data is, right? So we gain the insights and act on the complex issues by doing some sort of statistical analysis and the predictive models. Now, if you see here, what are the problems that are being solved by applying analytics? So it is how to increase the customer retention is one of the predominant area which is being used by many of the companies to, by applying the analytics over here. And the second one is how to maximize the profit. So what are the optimal parameters that are to be set so that the company will enjoy the maximum profits? How to increase the productivity of the workers? Now, what does the information technology initiatives really cost? Right? So you are going to estimate some sort of parameters over here given a set of variables to you. Now, having an understanding of this, so how the analysis works, so how the flow of the analytics works. So first you capture the data and you have the data with you and you try to understand what kind of data variables do we have. Generally, if you just look into the data, most of the data fall under qualitative variables or quantitative variables. So qualitative variables are those which are measured in the form of numbers. For example, the price of the product is a quantitative variable. The weight is a quantitative variable. Height is a quantitative variable, right? So these are the variables which are being measured on numbers. So hence those are called as the quantitative variables. Whereas if you come to the qualitative variable, name of the customer or the product name. So all these are qualitative variables which are being explained in a text format, right? So if you just take any database, so the database will be captured is a combination of both qualitative data and the quantitative data. Now, to conduct the analysis, it is always required to understand whether you have the qualitative variables or the quantitative variables or the combination of the variables, and accordingly you have to identify which would be the corresponding analytical technique that would help you to answer your query. So once you have understanding of the qualitative and quantitative data, you try to draw some sort of assumptions. So those assumptions are being tested by using the statistical techniques. And once the assumptions are being derived, then you will be moving ahead with the machine learning aspect of deriving the association between the input variable and the output variables. So this is how the flow of analytics goes with. So hence, if you just look into all these particular scenarios, the analytical concepts comes with the questioning. So the very first, you start with the question saying that are these two variables related to each other? So hence, let me take an example here. For example, we know this concept of demand and the price, right? So we say that, as the demand increases, the price decreases, or the demand decreases, the price increases. Now, what I'll do, I will frame out a question. I'll start with questioning. Does demand is related to price? Okay. So this is the question that I start with. Later, what I will do, I'll try to test this particular question. This is what my assumption. So I start with assumption saying that demand is not related to the price. So based on that, I will start this question and I will be testing this hypothesis by framing the null hypothesis and the alternative hypothesis, which we have seen in the descriptive statistics session. Right? So this is how the analytical framework goes with. So it is always better whenever you are wanting to apply the analysis over here, it is always better to go ahead and look at the data, maintain a data warehouse. So which we have covered in the DBMS part, and extract some sort of insights either through the visual representations or through by some sort of insights. So hence, based on this applications of analytics, we have actually the three types of analytics, which is called as descriptive analytics, predictive analytics, and prescriptive analytics, which you will be learning in detail in the further sessions. Thank you, everyone. Correlation analysis. Correlation analysis is one of the most important concepts in data analysis. Correlation analysis tells you the relationship between the variables. It helps you in measuring the strength and direction of the relationship between the two random variables. Now, what do I mean by this? For example, let us consider that I'm going to capture the price of the product and the profit earned by the company. Now, I wanted to find it out whether these two variables are related to each other, whether price is related to profit. Now, as price is numeric in nature and profit is also a numerical variable, so what I can do is I can go ahead and find the correlations. Now, if these two are being related to each other, if price and profit of a company are being related to each other, price, or we can also take sales here. Okay, so if the sales is being related to the profit, okay, fine. How is it related? Now, the moment when I ask you a question like how is it related, whether my question is if the sales increase, is price going to increase? Is profit going to increase? This is what my question is, or vice versa. If this is increasing, is this decreasing? Or it can also be as the sales increase, the price decrease, or the profit increase, the sales decrease. So whatever it might be, right? So I wanted to find, are they related to each other? If they are related to each other, are they related? What is their direction in which they are moving? Are they related in an upward direction? Saying that yes, if one parameter increases, the other parameter increases. Okay, are they related in a downward direction? Saying that if one parameter increases, the other parameter decreases. So this is what talks about the direction of the relationship between the two random variables. Now, if these two are related to each other, what is their strength of relationship? Okay, so this is what talks about the correlation. So hence, correlation helps you to find the relationship between the two variables. The formula to find the correlation is this. Generally, we do have the different kinds of correlations to be calculated. So one of the correlations is called as Pearson's coefficient of correlation. Which is represented with small r. And second, we have Spearman's rank correlation, which is represented with rho. Right? There is a condition to use this two correlations here. In order to use the Pearson's coefficient of correlation, the condition is that the two random variables, whichever you have chosen, should be numeric in nature. For example, the one which we have seen before, like sales and the profit, okay, or cost and price. Right? Now, in order to deal with the Spearman's rank correlation, this requires the two random variables to be on a categorical format. And whenever you have a categorical variable, that is nothing but your text variable, or which is nothing but your qualitative variable. But this qualitative variable should be measured on a ranking scale or on an ordinal scale. Okay, both the variables. So both two random variables. Then only you can use the Spearman's rank correlation. Okay. Now, in this particular session, we are going to deal with the Pearson's coefficient of correlation. So Spearman's rank correlation is not covered under this particular syllabus. Okay, so we are dealing with the Pearson's coefficient of correlation. Now, these are the three formulas which are used to calculate the Pearson's coefficient of correlation. Now, always it is found that the correlation value R lies between -1 and 1 plus 1. So that means if you find it out, if the sales and profit is being given to you, and if you calculate the R value, whether sales and profit are related to each other, and this value should lie between -1 and +1. We'll try to understand what does this -1 and +1 stands for. So before this, there is a myth which is prevailing in the industry saying that the correlation analysis gives you the causation. So please do remember, correlation analysis will just tells you the relationship between the variables, but it never talks about the causation here. Right? So some other examples of correlation. So number of hours of sleep and the test score, which are being tested by using the correlation analysis concept, whether average call duration is related to the age of the caller. But be cautious, it is not a causal relationship. It just gives you the association between the variables. Right? So hence Pearson's correlation coefficient, which is also called as a Pearson's product moment correlation, is used for measuring the strength and the direction of relationship between two continuous random variables x and y. With this, having a clear knowledge of the introduction to correlation analysis, in the next session, we will see how to interpret the correlation value and how to take one example and implement the same correlation analysis on Python. Till then, happy learning. Let us go ahead and understand how to interpret the correlation value. Whenever the correlation value is found to be positive 1, that is towards 1, it is called as strong positive correlation. Similarly, when the correlation value is found to be negative, then it is being termed as a negative correlation. If the correlation value is found to be 0, it represents that there is no relationship between the variables. Now, what do I mean by this? For example, let us take the sales and the profit of a company. Now you have extracted the correlation between these two values, and the correlation value is found to be somewhere around 0.98, which is towards 1. So this represents that these both variables are having a strong positive correlation. So the interpretation of the strong positive correlation says that if there is a unit increase in sales, there will be a proportionate unit increase in the profit. Or vice versa. If there is a unit increase in profit, then there will be a proportionate unit increase in sales. So this is how we interpret the value of correlation coefficient when it is positive. For example, let us assume that when the same sales and profit are being found, the correlation value is found to be minus 0.98, which is towards minus 1. This represents that they have a weak negative correlation. So this says that if there is an increase in the sale, then there is a proportionate drop in the profit. Or increase in the profit has a proportionate drop on the sale. So this is how we interpret the correlation coefficient whenever it is towards 1 and whenever it is towards 0. Generally, whenever the values are lying between 0.5 to 0.70 or 78, there is no thumb rule as such. So such kind of correlations are called as moderate correlations. And if R is equal to 0, generally most of the researchers say that there exists no correlation between the variables, but there might be a chance of both the variables, being unexplained. Okay, that concept will be learned later. This is how we interpret the value of correlations when it comes for, estimating the R value. Now let us go ahead and look into how are we going to understand the concept of this correlation. For example, let us assume that we are going to test whether the number of hours slept and what will be the test score obtained by the student. So for this, around 6 students' data is being collected, where it represents the number of hours of sleep and their test scores. It is found that if a student is sleeping for about 8 hours in a day, okay, his test score is around 81 out of 100. And if the student is sleeping for about 8 hours and he has obtained 80 and 6 hours, it is 75. Now we try to establish the relationship between these two variables and see what is the strength and direction of the relationship. Now, in order to understand the direction of the relationship, we try to visualize the data and try to understand in which direction are these both variables moving in. In order to visualize the data, when it comes for the two variables, we use something called as scatter plot to establish the relationship between these two variables. Now, if you see here, when this particular scatter plot is being obtained, it is found that as the number of hours of sleep is, it is very difficult to understand how the relationship is. So if there is a proportionate increase over here, there should be a proportionate increase over here, or if it is a positive or a negative. So hence, one insight what we have got from this is, we generally use scatter plot to find the direction of the relationship between the two variables. Now, having an understanding of what is correlation and where does the correlation value lie between and how to interpret the correlation values, now we are going and understanding, take one example and implement the correlations in Python. So see you in the practical session. Yes. Welcome back to this particular session on correlation analysis. In the previous session, we have seen that how to extract the call duration relationship between the call duration data and the age. Now, in this particular session, we are going to see how does Python enables us to extract the correlation where we can take it ahead and test the hypothesis. So in order to do so, what I'll do is I'll be working on the same file. So what I need to do, I need to start with an assumption first. So in the hypothesis testing, in the descriptive statistics, we heard that we need to frame some sort of null hypothesis and the alternative hypothesis. So null hypothesis starts with saying that I'm defining the null hypothesis. So saying that there is no relationship between age of the customer and the call duration. Whereas my alternative hypothesis, see, remember alternative hypothesis will be always opposite to the null hypothesis. So I say that there exists relationship between the age of the customer and the call duration. So this is what the hypothesis which is being framed. Now I need to test this particular hypothesis. Now in order to test this hypothesis, what I need to do is I need to extract the correlation value, and along with the correlation value, I need to look at something called as p-value. Now before I just go ahead with, in order to extract the hypothesis, we require a stats library from the SkyP package. So what I'm doing, I'm importing that. So from SkyP.stats import, what is it I wanted to import? I want to find the Pearson R. I told you, right, these both the variables are numeric in nature, so hence I require Pearson R value. So hence I'm just importing that particular package into Python right now. So the moment it gets imported, what we will do is we'll extract the correlation along with something called as p-value, which is equal to Pearson R of x, y. And I will try to print this result. The moment I print this result, you can see that, see, this is the same as your correlation value which we have obtained over here, right? And this is nothing but your p-value. Now this p-value says that 2.277 e power minus 11. That means here the p-value is 0.10 and 11. So this is how e power minus 11. So which takes that it is in a negative format. So as it is 11, after decimal we have to start. So this is the p-value. Now the criterion to decide on the hypothesis testing is that if the p-value is less than the required level of significance, which is nothing but alpha, and by default the alpha value will be 0.05, then reject H0, which is nothing but your null hypothesis. Right? So this is how our interpretation goes with. Let me turn this to a markdown. Yeah. Right? So the moment I say this, so here in the above, so p-value is less than null hypothesis, is less than 0.05, hence we are rejecting the null hypothesis. As we are rejecting the null hypothesis, it is found that the alternative hypothesis is correct, which means that there exists relationship between age and call duration, and this relationship is going to be negatively related to each other. So this is how we try to establish the the hypothesis testing and extract the correlations based on the SkyP package and the NumPy. Hope you all enjoyed this particular session on correlations. See you in the next session with further little more advanced analysis. Till then, happy learning. Let us go ahead and extract the relationship between the call duration and age of the customers in Python. So for this particular problem, we are going to use a data set which is called as call duration data to implement the correlation analysis. Now let us go and see how can we implement this on Python. For this, I require to open the Python Jupyter notebook file over here. So in order to go ahead with this extraction of the correlation between the call duration and the age, first I need to import the data into this Jupyter notebook. In order to import the data into the Jupyter notebook, I require some sort of libraries or the packages. So I'm calling for the requisite packages into Python right now. So hence, as we have discussed in the last session, I require pandas libraries to import the data, and I require NumPy to do some sort of statistical operations. So hence, I have imported both the libraries, import pandas, pd, and import NumPy, np. Now, I should import the dataset into import the dataset. Now, in order to import the dataset, I should give a label to my data. So hence, I'm calling my data to be imported as data, and I'm calling for the pandas library, and I'm saying that I wanted to read. And what I should read? I want to read an Excel file. Now, where is this Excel file? This Excel file exists in the path where I have stored my data file. Right? So where did I store my data file? I have stored my data file under our users Chandrika desktop content. So I have to find out the path where exactly I have stored this particular data file. So what I'll do, I'll go here. So this is for the people who don't know how to extract the location of the file. I'll go to this video content. So here I wanted to extract the duration data over here. So I'll do right click on this and I'll call for the properties and go to the security, copy this path and take it into Python within inverted commas. So the moment if you don't do this, after doing this, actually Python will not read this exactly. So whenever you have a backslash over here, it generally understands that it is an HTML document and we have to say that it is a data set. So hence I'll be adding R over here and run the file. So the moment I run the file, the code got executed. I have to check, and I wanted to check the first 4 rows of the data set. To do this, I'm using a function called head. So in order to extract the first 4 rows, we use a function head. If you want to check the last rows, we use the function tail. I want to know the last 6. Right? So this is how we define this data. Now, I wanted, as I told you in the correlation, while we were discussing about the correlation analysis, I said that we try to visualize the data to know the direction in which these 2 variables are moving in. Now, in order to visualize the data where both the variables are numeric in nature, generally we use a scatter plot, right? Now, in order to use a scatter plot gives you the visualization with x and y axis. So hence, I should tell Python that what is to be taken on x and what is to be taken on y. So hence, I need to define my x. So I'm taking that I want x to be, that is the x axis to be taken as the age. So this age is stored in my data, okay, and I'm calling for age. Let us run this. So it got executed. And similarly, I'm defining y is equal to data. And what else is left out? It's called duration. I'm running this. So x and y got executed. Now to get a scatter plot, we need to call upon for a package called as matplotlib. So what I'm doing now, I'm calling for the package import matplotlib.pyplot as plt. Okay. Now on this, I'm going to extract the scatter plot right now. So what I'm doing, I'm extracting the scatter plot. So plt, because I've given the short form to my matplotlib function, dot scatter of 2 variables, x comma y. Be cautious if at all if you have used small letters of x and y, take it as x and y. You can use a, b also. Okay, let me extract this. Yeah, so the moment you extracted this, see here, you can see the scatter plot over here, right? Now, how are we going to interpret the scatter plot? Now, as and all your x-axis is increasing, your y-axis is decreasing, right? So this is how you interpret the scatter plot. Now, to write the interpretation, what I'll do is, so from the scatter plot, it is observe that as the x-axis, as the age of the customers are increasing, the call duration is decreasing. So this is how I interpret the results. Now see, the moment you don't want this in, you wanted this description to be visible as a text. So what you can do, you can go here and give it as markdown. So the moment you give it as a markdown, it understands that it is no more a script line. So hence it is a text line, right? So enter it. So the moment I enter, it will again enable you the script line. Okay. Now I want the correlations to be obtained, right? So what I'm doing here, I'm taking data dot correlation of x comma y. Okay. Okay. 2 tables. Okay, fine. Let me take data dot correlate. I'm sorry. Yeah. Yes. So data dot correlation. So it extracts you the correlation matrix. So it says that age to age, that is the correlation between the same variable is 1. Whereas the correlation between age to call duration is minus 0.95. Similarly, if you see here, call duration to age is minus 0.95. And so I need to write it. So the relationship between age and call duration is found to be weak negative correlation. Hence, it can be interpreted that as the age of the customers increase, there is a proportionate decrease in the call duration. Now I don't want this to no more be as a script. So what I'll do, I'll go here and change this to markdown. Right? So this is how I can obtain the correlations on the call duration data by taking the age as one column and the call duration as another column. Actually, in correlations, what we can do is correlations will enable you to do the hypothesis testing also. So in the next session, we'll be going and learning how to extract or how to conduct a hypothesis testing by taking the correlation analysis. Thank you. Having this understanding of correlation analysis, see, in the correlations, what we have done, we have tried to find the relationship between the variables and what is the strength of the relationship between the variables, right? In the regression analysis, we are going to find how is the association between these variables. Now, in order to study this, let us go ahead and understand what is regression at first. Regression is a tool for finding the existence of an association relationship between a dependent and an independent variable. Now, before going into this, let us understand what is a dependent and an independent variable. Let us take one example. I'll be taking the same example of the sales and the price. Now, my problem statement is to estimate the sales given the price of the product. Now, if you look at this, what is it I'm going to find here? I'm going to find what would be the sales. In order to find the sales, what is the data given to me? The price of the product has been given to me. So hence, this sales is a dependent variable and it is dependent on price. So hence, price is an independent variable. So hence, in the regression, what happens is it gives you a function of price. So it tells you that sales is a function of price. So hence, you are going to establish an association between the sales and the price. Right? So this is how we define the dependent and the independent variables. Now, while you are defining this dependent and independent variables, a relation can be linear in nature and a relation can be non-linear in nature. Now, what do I mean by this? Whenever a relation is linear in nature, what happens is, as you take, for example, if I just take sales on x-axis and price on y-axis. So as the sales is like this, so it might be increasing. That means as the sales are increasing, prices are also increasing. So if I just try to draw a line out of this, all this forms a straight line, which is nothing but your linear equation, right? So hence it can be linear in nature. Sometimes it can be non-linear in nature, which might be a quadratic form, right? So hence the relationship between the variables can be linear or non-linear. Now, the dependent variable measures the outcome of the study, whereas an independent variable will give you or will explain the change in the outcome variable. Right? So this is how you find the set of values for the explanatory variables to see how the response variable is able to predict. Now, having an understanding of this, what is regression? So regression is one of the supervised learning algorithm in the machine learning terminology. It is one of the important tool in predictive analytics because here, if the sales is being given, if you are asked to estimate the sales given the price, that means you are going to predict what would be the sales. If the price is 2 rupees or if the price is 3 rupees, so what would be the sales over here? Right? So hence it falls one of the important tool in predictive analytics. Now, regression model established the existence of association between two variables. Again, as we have discussed in the correlation, again, it is not a causation. Now, what do I mean by this? For example, let us assume I understood that sales is equal to 2 times of price. For example, okay. Now, how do I interpret this? So, if the price of this particular a product is increasing, then the sales are also increasing. If the price is decreasing, then the sales are also decreasing. Right? So, this is how generally I interpret this particular equation because it is 2 times of price and it carries a plus sign over here. But It doesn't mean that the decrease in sales is because of increase in price. No. What does this tell you? The increase in sales, price plays one of the parameters in the increase of the sales. But price is not the causation either in the increase or the decrease of the sales. So hence, we say that regression is not a causation. Just like how correlation helps you to validate the hypothesis, in the same way, regression also helps you to validate the hypothesis. Some of the hypotheses which are being taken from the U. Dinesh Kumar's textbook of business analytics tells you these are some of the hypotheses where the regression analysis has been obtained to understand the relationship or the association between these variables. Now, going ahead with this interesting hypothesis. Okay, moving into this particular regression definition is the statistical technique that attempts to determine the existence of a possible relationship between the dependent and the independent variables. Now let's go ahead and understand how we can take this, how we can establish the relationship and how can we validate the hypothesis. Now, defining of a dependent and the independent variables is quite necessary in the regression analysis, but it not be a causal relationship. Regression is not designed to capture the causality. The purpose of regression is to predict what would be the value of the dependent variable given the independent variables. Right? So there are certain nomenclatures which are being followed for the dependent variable and the independent variable. Some of the researchers call them as explained variable or exploratory variable. Some call it as recurrent or recursor. Some call it as predictant or predictor. Some call it as endogenous variable and exogenous variables. Some call it as controlled or control variables. Some call it as target variable or the response variable and the stimulus variable. Some call as a feature and the outcome variable. Right? So don't get confused with this particular terminology. Now going ahead with this. So as we see that what is the difference between the regression and the correlation? Regression is the study of existence of relationship between the variables. The main objective of the regression is to estimate what would be the change in the dependent variable provided the independent variable is given. Whereas correlation is the study of strength of relationship between two variables. So now, by this moment, we have a clear understanding of what is regression, what is correlation, and what is the difference between the regression and the correlation. And regression also helps you in validating the hypothesis, and it is one of the important tools in predictive analytics. Going further, we'll be learning much more about the regression analysis. Till then, happy learning. Let's understand about the types of regression models. As discussed earlier, the relationship between or the association between the two variables can be linear or non-linear. Now, whenever you just look at, depending on the linearity and non-linearity of the variables, there are different types of regression models. The regression models with one independent variable and with more than one independent variable. So whenever we are having a one independent variable exactly, so then we use something called as simple linear regression, and the simple linear regression can be linear or non-linear. Whenever we have more than one independent variable, we use something called as multiple linear regression, and the relationship or the association can be linear or non-linear. Now, having an understanding of this, so what do we exactly do? Now, if we have one dependent variable, and if the nature of the dependent variable is found to be numeric in nature, then we call that as so one dependent variable and exactly one independent variable. And if this is also numeric in nature, and in this also it is numeric in nature, then we call this as a simple linear regression. If you have one dependent variable which is numeric in nature, and if you have more than one independent variable which is either numeric or non-numeric in nature, then we call this as a multiple linear regression. Right? So if your dependent variable is non-numeric, that is categorical in nature, carrying two responses of yes or no, and more than one independent variable which can be numeric or non-numeric, then we use something called as binary logistic regression. If you have categorical variable with more than two responses, then we use multinomial logistic regression. Right? So these are the different regression models that exist depending on the nature of the variable what you have. Now going ahead with this. So simple linear regression, the general equation of the simple linear regression goes with y is equal to beta naught plus beta 1 x1 plus epsilon, where beta naught and beta 1 are the, in fact, beta 1 is the regression coefficient, beta naught is the intercept. Okay. Now if you see here, this epsilon, I'll come back to this. This is the unexplained variance. Okay. Now moving ahead with this, the general equation of a multiple linear regression model, it is same as, but only the thing is, as you have more than one independent variable, it will be just getting added over here saying that beta 1 x1, beta 2 x2, and so on, beta n xn. Right. So the non-linear regression looks like this. Okay. So in this session, we are going to discuss about the simple linear regression right now. Now, when it comes for the linear regression, so the linear regression stands for a function which is linear in nature. Right? So hence the following equation will be treated as the linear regression itself, and for the simple linear regression model, the equation that we use is y is equal to beta naught plus beta 1 x. This is the simple linear regression that will be used for. Now, in order to go ahead with this, so whenever we are trying to find the association, we call that particular concept as the regression model development. Now, in order to go ahead with the regression model development, there is an analytical framework that is to be followed. So before you go ahead and find the association between the dependent and the independent variables, there are certain steps which are to be followed. And those particular steps will be explained to you in the next session. See you all in the next session. Welcome to the session on regression model development. Now, whenever we are going to build a regression model, we are supposed to follow certain steps. First step is to import the data, which is nothing but the data collection. The second one is to go ahead and do the exploratory data analysis, where you will be exploring the relationship between different columns. And then you will go ahead and try to find the association between the variables by looking at the significant variables in the models. And then we look at the evaluation parameters. Now, when it comes for the data collection, okay, so and these particular techniques, let us look at some of the practical implementations of simple linear regression model. So some of the examples that have adopted simple linear regression model might be a hospital might be interested in finding how the total treatment cost of the patient varies from the body weight of the patient. E-commerce companies such as Amazon, Basket, and Flipkart would be interested in knowing the number of customers they visit their portal and what would be the revenue generated by them. Retailers such as Walmart, Target, Reliance, Retail, Hypercity, etc. would be interested in understanding the impact of price cut proportions on the revenue of their private labels. Original equipment manufacturers would like to know the impact of duration of warranty on the profit. So these are some of the examples which are the simple linear regression model. Now, going ahead with this, the steps of the simple linear regression model building. The first step, as we have discussed, is nothing but the collection or the extract of the data. So extraction of the data plays a very important role. So whenever the data is being available under different sources, so you need to identify the key problem and take the data collection. Sometimes this data collection might be time consuming or expensive. There might be some sort of ERP systems which are existing within the companies to collect and sort the data. So hence those particular systems enable you for the data extraction process. So another example of the data collection is it can be expensive because you might be spending some sort of time in capturing the data through the observational studies. So hence it can be expensive too. Now coming down to the second step of pre-processing the data. Pre-processing the data is one of the crucial role in model building. Without pre-processing the data, it would be difficult for you to go ahead and do the model building. So hence, while it comes to the pre-processing of the data, the important aspect that it has to be kept in mind is to have the variables which are exactly related to the problem statement. And you might be having the categorical variables which are on nominal scale and are on numeric scale, ordinal scale. So hence, this data cannot be processed directly, and hence it has to be modeled out, right? And coming to the third step, which is nothing but divide the data into training and validation. So generally, what we do is we try to divide the data into train, test, and test set in order to see whether the model performs very well on the new data. So there is no thumb rule for the training and the test set. Generally, it is 80-20 or 70-30 depending on how big your data is. Now perform descriptive analytics by extracting the mean, that is the measures of central tendency, how far the variables are there any outliers in the data, comes under your fourth step of performing the descriptive statistics or descriptive analytics. Then try to obtain the functional form of the regression. So if you are using the simple linear regression model, identify what is the dependent variable and what is the independent variable, and then go ahead and see what is the functional form of this. Sometimes you may also require to do the visualization of the data here by looking at the scatter plots. So this is how you try to find the linear relationship between the variables. Now coming to the second step, the last step, which is estimation of regression parameters. So you need to estimate the regression parameters in the simple linear regression model. We will be using a methodology called as ordinary least squares method to estimate the regression parameters. These regression parameters should fit the line that is set for the data points. So this process you will be understanding further in still more detail in the coming sessions. OLS provides the best linear unbiased estimate, that is, where the population parameter and the estimated parameter value from the model is. So perform regression model diagnostics. Whenever you are performing a regression model diagnostics, you have to see necessarily whether the model which you have extracted is in the functional form, and whether the model which you have extracted is fulfilling all the assumptions of the requisite model. Then only you can say that the model is the best model to go ahead for the deployment. Validate the model based on certain parameters. So each and every model has a different parameters. In fact, the model may be cross-validated using multiple training sets or the test sets and decide on deployment of the model here. So these are the 9 steps that are to be followed when it comes for estimation of simple linear regression model. So estimation of the parameters using ordinary least squares method includes that identifying the dependent variables and independent variables and what is the random error associated
calculator with the best equation in order to find the relationship between the dependent and the independent variables. So these are the 9 steps to be followed, which is called as an analytical framework to be followed to extract the association between the dependent and the independent variables. In the next session, we will go ahead and look into what are the assumptions of simple linear regression model, and then later we will practically implement the simple linear regression model on Python. Till then, happy learning.
In the last session, we have discussed about what is simple linear regression and what is the analytical framework behind the simple linear regression model. In this particular session, we are going to talk about what are the assumptions of simple linear regression. So when it comes to the assumptions of simple linear regression, so it clearly says that it follows the method of a least squares method to find the best fit line passing through the data points of x-axis and y-axis. Hence, the assumptions of the simple linear regression model are the regression model should be linear in nature with regression parameters. That means it should take the form of a straight line.
And the explanatory variables, that is nothing but your independent variables, should be deterministic in nature and cannot be stochastic in nature, which means that your independent variables should be numeric in nature. It cannot take the probability values. Coming to the third assumption, the expected value of the errors should be 0. In the case of time series, residuals are uncorrelated, and that is the covariance should be equivalent to 0. So this particular assumption of simple linear regression will be well addressed whenever you are learning about the time series forecasting, because whenever it comes to the time series data, your data will be time dependent, and hence there should not be any covariance. Coming to the rest one, the residuals should follow a normal distribution. After fitting the regression line, you will be in a position to extract what would be the predicted values. The difference between the predicted values and the actual values is called as the residuals. Now, whenever you plot the residuals should be normally distributed. And the variance of the residuals should be constant across all the values. Now, whenever I say the variance, whenever you take the variance of the errors, those variants should be constantly spread across, and whenever they are constantly spread across, then it is fulfilling the property of a homoscedasticity. Whereas, if the variance is not normally spread across, then it is called as the heteroscedasticity. In order to understand the homoscedasticity and heteroscedasticity, we will plot the residuals and the variance of the residuals, and we will see the visualization. So whenever your residuals and the variance of the residuals are taking the form like this, which are being constantly spread across, like this, then it says that it is homoscedastic in nature. Whenever your residuals and variance of the residuals are taking the shape like this, that is, which is nothing but a funnel shape. So if you just take the external data points, it takes the shape of a funnel. So if it is taking the funnel shape like this, then it is called as heteroscedastic in nature. So one of the assumptions of simple linear regression model is that your residuals, the variance of the residuals, should be homoscedastic in nature. So these are the assumptions of regression model. Having understanding about what is regression, what is the analytical framework, and what are the assumptions of the regression model, let us go ahead and build the regression model right now. In order to develop the simple regression model, we use the data set which is called as company data, and we will also look into the results and how to interpret the results. So before we go ahead and develop the simple linear regression model, let us go ahead and understand or look into the data what exactly the company data is capturing about. Now, to go ahead with this, so this is the data which is being captured by the company. The company is interested in knowing the sales whenever the TV advertisement, the radio advertisement, and the newspaper advertisement costs are being given to them. So the problem statement here is to go and estimate the sales given the radio, TV, and the newspapers are being given over here. And when it comes for the simple linear regression, as we have discussed earlier, in order to go ahead with the simple linear regression model, you should be having a dependent and an independent variable. Whenever you look at this particular problem statement, we are going ahead and extracting or developing a simple linear regression model for the sales. So hence, sales is being considered as a dependent variable, whereas this newspaper, radio, and the TV cost are being considered as the independent variables. Now, we will go ahead and then see how to extract the simple linear regression model in Excel first, and then we will go and extract the same models in Python later. Now, one of the conditions to see and to find it out whether we can apply the simple linear regression model is, by looking at the assumptions, we have to make sure that the dependent variable is having a linear relationship with the set of independent variables. So whenever we say the linear relationship, we need to see that the correlations between sales to newspaper, sales to radio, and sales to TV should be linearly related to each other. So in order to do this, generally we will go ahead and look at the scatter plot. So before we go ahead and look at the scatter plot, let us understand how to extract the scatter plot, and this will be continued in the next session.